let's see the other side of the bacterial resistance story. Welcome to Critical Thinking Scan, where we look at how you can think about any faith-challenging message and arrive at a biblical, logical conclusion yourself. I'm Patricia Engler, and today let's finish with part 2 of how to think critically about the textbook claim that bacterial antibiotic resistance is evidence for Darwinian evolution. We're at check number 6 of the 7 checks of critical thinking, check for interpretations. And that requires knowing what's really going on in the observational science of bacterial resistance. For example, all my textbook said when explaining how some Staphylococcus aureus bacteria became drug-resistant to penicillin was that the penicillin-resistant ones had an enzyme, penicillinase, that could destroy penicillin, and that some methicillin-resistant bacteria could synthesize cell walls using a different protein that was not affected by methicillin, which normally weakens bacterial cell walls. But the textbook didn't explain exactly where these resistance mechanisms came from. It just said they were examples of evolution. So to see what was really happening, I had to dig a little deeper into relevant studies and into the resources like the ones you can find linked to this video. And like you can learn from those resources, it turns out that bacteria can become drug resistant a number of different ways. For instance, mutations can cause bacteria to lose control over how much protein they make from certain genes. So they overproduce proteins that destroy antibiotics or help remove drugs from the cell. That's what my textbook didn't say about the penicillin-resistant bacteria. They already had the genetic information to make penicillinase. They just lost control over how much they produced. Or sometimes, mutations cause defects to proteins that normally let antibiotics enter or bind to bacteria. That's what happened with the methicillin-resistant strains my textbook mentioned. Normally, methicillin binds to a protein called PBP2 that the bacteria need to build their cell walls. But many resistant strains have a mutated version of this protein called PBP2A, which are deformed so that the antibiotics can't bind. Like any mutation, this isn't the creation of new genetic information so much as the corruption of existing genetic information. And evolutionists are still left to explain where that information came from in the first place. Now, something cool about bacteria is they can pick up genes from other microorganisms and from their environment through a few different mechanisms. But again, even though the gene might be new to that bacterium, it's not a completely novel gene. It had already been existing somewhere in the environment. And it's the origin of functional new genetic information which would be required for one kind of organism like bacteria to eventually evolve into completely different organisms like horses or humans, with thousands of genes for hearts and brains and all their other interconnected, interdependent components. Besides, another thing my textbook didn't mention is that while drug resistance could be considered a beneficial mutation to the bacteria exposed to antibiotics, those mutations often come at a price, frequently involving some loss of function or efficiency. For example, normal PBP2 proteins in the bacteria my textbook described can link together both sugars and peptides for building cell walls. When methicillin binds to PBP2s, they can no longer link peptides together. The mutant proteins, which can't bind methicillin, can still link peptides together, but because they're mutated, they can't link sugars. So the cell needs both mutant and normal proteins working together to maintain the cell wall when exposed to methicillin. With only the mutant protein, however, the cell wouldn't even live. In the same way, many superbugs with resistance to multiple antibiotics have so many mutational defects that they can't outcompete normal bacteria under normal conditions. If that wasn't enough, something else that's not often clear from textbooks is that multiple studies have identified drug resistance in ancient bacteria, as other microbes produced antibiotics long before modern medicine. For instance, a study on antibiotic-resistant bacterial DNA in supposedly 30,000-year-old Canadian permafrost revealed what researchers called conservation of gene sequence and symptony with modern resistance clusters in the clinic, as well as protein function and structure. In other words, the supposedly 30,000-year-old bacteria looked and acted like modern resistant bacteria, right down to their DNA and proteins. Altogether then, far from being textbook evidence for evolution, the observational science about bacterial resistance is consistent with the biblical worldview. For more on how to think critically about any faith-challenging message, you can access my other CT scan videos packed with tactics, tips, and tools that helped me as a Christian student at secular university. Thank you for watching. Hey, it's Patricia here. Just wanting to let you know that if you like these videos, a free, easy way to help Answers in Genesis Canada create more content and equip more people to defend their faith is to hit that like button, subscribe to our channel, click the bell, and of course, share these resources. That lets the social media algorithms help these videos reach more people who can benefit from them, saving us advertising expenses while promoting biblical authority. Thank you so much.